In this video, we're going to explore and use the product, quotient, power rule, and change of base formulas for logarithmic expressions and functions. We're going to expand and condense logarithmic expressions using these rules for logarithms. So the first thing I want you to do is write down as many of the rules of the exponents that you remember. And the reason is if you remember that logs are just the inverses of exponentials. So when you have two bases that are the same with, say, a to the m multiplied by a to the n, the rule of exponent would be a to the m plus n. And notice that's what we do here. When I have the log base b of m multiplied by n, to break this apart, to expand this out, is notice that it becomes an addition between them. So I have the log base b of m plus the log base b of n, provided, of course, the base is greater than 0. So using the rules of exponents and expanding these out, this first one just becomes the log base b of x plus the log base b of y. The second one, let's just bring this in. This is the log based 4 of 5 plus the log based 4 of 64. Now, this term does not reduce or do anything more than the log base 4 of 5. Now, I can use my calculator and I can find a decimal equivalent. However, for this part, I know that 64 is 4 to the third. So the log based 4 of 64 is really the log base 4 of 4 to the third, which we know from our last videos, this is just 3. So then this reduces to, or simplifies to, the log based 4 of 5 plus 3. On C, we're going to expand it out, so it is the log, or the natural log of e, plus the natural log of y, plus the natural log of x. And again, we know that this is equal to 1. So this becomes 1 plus the natural log of y plus the natural log of x. The quotient rule for logarithmic functions, or logarithmic expressions, is the log base b of m divided by n is the log base b of m minus the log base b of n. And in the land of exponent rules, I have a to the m divided by a to the n. This becomes a to the m minus n. And notice that's what happens here. When I am dividing m and n and I'm taking the log of that, base b, then I can subtract the logs. Now we're going to expand these out. So this is the log based a of x minus the log based a of y. Whatever is in the denominator becomes a subtraction. So this is the log based 4 of 5 minus the log based 4 of 64. But we know from our previous example this is equal to 3. So this is the log based 4 of 5 minus 3. This is the natural log of e minus. Now in the denominator I have the natural log of x multiplied by y, which means this is, well, we'll take care of this. We know this is equal to 1. So it's going to be 1 minus the natural log of x plus the natural log of y, because multiplication is going on between them. And if I want to, I can distribute the negative 1 through, and so I have 1 minus the natural log of x minus the natural log of y. And that's what that expands out to. The next rule of logarithmic expressions and functions is if I have the log base b of m raised to the n, this power, which is on the m, not on the log, but this power, which is on the m, can come out front as a multiplier. Rule of exponent was if I have a to the m multiplied by the n power, this is a to the m multiplied by n. This is the power to power rule for exponents. Now, we have to pay attention that the 4, which is the exponent, is on this and not on the log. So we can rewrite this as this 4 is going to come out front as a multiplier. Log 4 multiplied by the log based a of x divided by y, which becomes 4 the log based a of x minus that 4 distributes onto the denominator when I expand out, so it's still a 4 log based a of y. Now this exponent is only on the x and this exponent is only on the y. So when I expand this out, it is going to be the log base 4 of x squared minus the log base 4 of y to the 5th, which becomes 2 the log base 4 of x minus 5 the log base 4 of y. Similarly, I'm going to pay attention to where I see these exponents and who owns, quote, owns those exponents, where do they belong? This becomes the natural log of e to the 3rd minus the natural log of xy to the 6th. This is just going to be 3. So 3 minus. I'm going to bring this 6 out front as a multiplier. This 6 will come out front as a multiplier of the natural log of x multiplied by y. So this becomes 3 minus 6, the natural log of x, minus 6, the natural log of y. And the step that I had right here is I know that I'm going to have a negative 6 multiplied by the natural log of x plus the natural log of y. And then all I did was I distributed the negative 6 through. Now here are some other rules. Some of them we actually have explored in class. We have the log based a of a to the x has to equal x. And the reason this has to be true is when I turn this into its equivalent exponential, I have a to the x has to equal a to the x, which makes total sense. So the natural log of e to the x is equal to x all day long, just like the common log of 10 to the x is equal to x all day long. The other one I have, which is this one, this makes sense as well, and we did talk about this in class, that if I turn this into its equivalent log, I have the log based a of the answer, which is x, is equal to the log based a of x, which was the exponent. Now you're like, what? Okay, let's turn this back. This base to this power equals that. So what does this look like when I have something other than a? Well, let's do the common log. So I have 10, the log of 6 is equal to 6. I have e, the natural log, that was a terrible natural log. Let me try that again. The natural log of, say, 3 is equal to 3. Or if I have 2, the log base 2 of 64, this is equal to 64. Two other ones that we have are the log based a of a is 1 and the log based a of 1 is 0. Now what I'm going to do is I'm going to bring these back together. We spent time expanding, now let's condense this. First thing I want to do is make sure that my bases are the same and I pay attention to what's going on between them. They're both base a, and that's a plus. That means this will be the log based a of 75 multiplied by 2, or the log based a of 150. These are the same base, and it's a subtraction going on between them, so this is equal to the natural log of 54 divided by 6, which is 9. This is the natural log of 9. They all have the common log here. Ooh, what do I do with that? Well, I'm going to use the fact that if I know that the log of 10 of x is equal to x, this tells me the common log of 10 to the 3rd must be equal to 3. So I'm just going to rewrite this as 1/3 the log of a minus the log of 2 plus the log of 10 to the 3rd. Now, if it is a subtraction, it'll go on the denominator. If it's an addition, it'll go on the numerator. And this power here is owned by this a right here. So this becomes the log of a to the 1/3, 10 to the 3rd, divided by 2. So this is, reducing this down, so I have the log. 10 cubed is 1,000, divided by 2 is 500, a to the 1/3, and that's my final answer. Anything with a plus goes in the numerator, anything with a minus goes in the denominator. Ooh, and I'm going to take this 1, I'm going to rewrite this as the natural log of e, which is equal to 1. So I'm going to rewrite this as the natural log of 2x plus 3, the natural log of x, minus 3, the natural log of y, plus the natural log of e. I'm just going to erase this. So plus the natural log of e. So this becomes the natural log of 2x, that stays in the numerator. The y to the 3rd, because this becomes the exponent and it's a negative, so it goes on the denominator. This 3 goes on the x, and this is a plus, so it's going to stay in the numerator. So this is going to be another x cubed. And this is a plus, it'll also stay in the numerator. So this becomes the natural log of 2e x to the 4th, y to the 3rd. And that's what that one equals. Okay. And let's do this last one. This exponent is going to go on, this multiplier up front is going to go as an exponent there. The same as this, and that one's okay. And so I'm going to have the natural log of x squared minus 9 raised to the 3/2 minus the natural log of x minus 3 raised to the 3/2 plus the natural log of x plus y. This negative tells me that this will go in the denominator. This is positive, so that will go in the numerator. So this becomes the natural log of x squared minus 3 raised to the 3/2 x plus y over x minus 3 raised to the 3/2. And this should be 9. Let me change that to 9. Now notice that this factor and this factor have the same common exponent. And not only do they have the same common exponent, I know that x squared minus 9 is x minus 3 and x plus 3. So I can write x squared minus 9 raised to the 3/2 over x minus 3 raised to the 3/2 as x minus 3, x plus 3 over x minus 3, all raised to the 3/2, because this exponent matches this exponent. And the rule that I'm using is if I have a to the m, b to the m, I can write this as a over b raised to the m, or I can go this way. So then what happens here is my x minus 3's cancel. And so in simplified form, this is the natural log of x plus y multiplied by the x plus 3, that is what did not cancel with a simplification, raised to the 3/2, and that is that answer. Now the change of base we talked about in class because our web work will not take the log base 2, so we actually have learned the change of base last week in last classes. So if we have the log base be of m, we can use the common log, we can use the natural log, or we can use whatever log base we want. So if I'm asked to use the change of base, I can use whatever log base I want. And I'm going to put this in my calculator. So I can write this as a natural log of 12 over the natural log of 3, which is the same thing as the common log of 12 over the common log of 3. I'm going to put that in my calculator. Give me just a moment. So I'm going to use natural log because it's easier. I just like to write it, and it's just less to write. I'm going to do the natural log of 12 divided by the natural log of 3. And in my calculator to 4 decimal places is 2.2619. I'm going to use the common log here because why not? So I have the log of 100 divided by the log of 5, which I again can write as a natural log of 100 divided by the log of 5. Doesn't matter which one you use, they will give me the same answer, and you can check it on your own. So I'm just going to put this in my calculator really fast. And to 4 decimal places is 2.8614. And then my very last one is I'm going to write this as the natural log of 60 over the natural log of 9, which could be wrote as the log of 60 divided by the log of 9. Either way, it does not matter. So I'm going to put this in my calculator, and I'm just put that in my calculator right now. I'm going to get 1.8634. And that's it for this video. Nice short one. I'll see you in class.